get going here. This is our Blower Door 101 presentation. My name's Sam Myers. I'm with RetroTech. We are one of two blower door manufacturers, the other one being the Energy Conservatory. So obviously I'll be focusing on on our equipment, but really when it comes to blower doors, both brands work the same way. It's the same type of equipment. You know, one's Ford, one's Chevy, so just pick whichever one you like. But I'll be using ours as an example just to kind of show how this equipment is set up, why we test, why we care about air tightness, what the equipment looks like, what comes in a blower door kit, and how you set it up, and then how you get the reading that you want to get. So with that, we'll get going. A little bit about myself. I kind of serve as RetroTech's in-house building science consultant. Used to be a HERS rater for an engineering firm in Raleigh, North Carolina called Advanced Energy. So I'm a recovering HERS rater, I guess. So I used to be in the field quite a bit doing this kind of thing. So let's start off with air tightness and why we care about this sort of thing. Why do we test houses for air tightness? Sometimes code requires this, or from a builder standpoint, it can be for quality control. If a builder says they build great houses, it's nice to have the papers to prove it, to go along with it. And it also, depending on how air tightness affects you, it really depends on what climate zone you live in. I live in the Southeast, down here in Wilmington, so we get pretty hot and humid during the summer. So humidity is a big thing that has a relationship with air tightness of the houses that we live in and that we build. It also depends on how stack effect is going to handle that building as well. So sometimes we run into different problems, whether we live in hot or cold climates. So one of the biggest topics when it comes into air tightness now is indoor air quality. It used to be all about energy. And so this is a nice little mock-up that my friend Joe Madosh built to show what kind of stuff can end up in a stud bay in an older leaky house. And obviously, as you can see, it's not very clean. This is Larry Zarker from BPI taking a nice whiff of what's going on in there. But if you think about the air you breathe inside your house, where does it come from? It comes from outside. And how does it get in? Through leaks within the building. And it brings other things with it: humidity, dust, pollen, sometimes pests, and whatever the pests leave behind, and on and on and on. So all those things end up in our lungs at some point. So indoor air quality has definitely been a hot topic, for the HVAC community, for the building community here for the past few years. And so air tightness plays a huge role in that, as well as keeping all kinds of pollutants out, keeping pests out, and things like that. So when we started, blower door testing, really back in the 80s, it was all about energy. We want to keep our energy bills low, and of course, we're still doing that. It's a huge benefit to making airtight homes. But chances are, if you're having an existing home that's having issues, chances are they're going to call to come to get help about comfort before they will energy. Comfort sells more than energy does. That's just what we've seen across the country. But indoor air quality is coming up too, just as important, especially for people that have COPD, asthma, things like that. Having an airtight, well-ventilated home really helps with those symptoms. And so this chart kind of breaks down where some of our issues come from and how they impact. So floors, walls, and ceilings, for existing homes, if we're going to try to patch stuff up, a lot of our problems are going to be solved at the ceiling and down at the floor if it's a crawl space or a basement. Duct leakage is also a part of our blower door number, so having tight ducts is important. People used to think it was windows and doors were the majority of it, but as you can see, that's about 20%. It's these other places that we can't really see with the naked eye, and that's why blower door testing and then having other tools as well, such as smoke emitters and thermal cameras, can really help us see where those issues are located. So when talking about air tightness of a house, we have to get familiar with this term called the air barrier or the pressure boundary, whichever one you want to call it. They're interchangeable terms, but it's basically that part of the house that defines inside from outside. It sounds pretty simple, but with more complex building types, it can be kind of tough to determine where that is, especially if you have a spray foam attic that may be adjacent to other vented attics, it changes. So So it's important to know where that is, because that's the pressure boundary that we're actually testing. And that's where those problems are occurring. So if it's like your typical house with a vented attic, this blue line coming across here at the top of the ceiling is going to be our air barrier here. And so that's the ceiling drywall. But we also have to include everything that goes onto that. So if you think about all the penetrations that are in a ceiling, that's where problems are coming from. So if we have ducts in the attic, can lights, junction boxes, ceiling speakers, things like that, that's going to cause issues. And one thing, one of the leakiest parts of a house that people don't realize is where this drywall meets the top plate. And you have this crack down the middle here. And if you think about how many tops of interior walls that you have that are have hot attic space above it, that ends up to be quite a big hole. So thermal boundary, air barrier, whichever one you want to call it, it's good to get familiar with that and learn where that is on the plans and how that's going to impact the house when you run your test. This is a diagram we drew up when I was at Advanced Energy to kind of show where this air barrier is for new construction. We like to put it on the sheathing. So there's great products out there to help out with that, like Zip System. That'll actually help you build airtight walls. But then you have these transitions for windows and ceilings. And then the special points there where you have to pay attention to when you're air sealing that maybe products like that won't cover. And then as it transitions to the ceiling here, like I was talking about before, where your duct penetrations are, lights, things like that. So as you can see here, anywhere that there's a hole going through, it's going to cause a problem. Or if you're walking the house during framing and you can see daylight, chances are there's going to be an air leak there. It looks like they caulked part of the stud pack here, but then kind of gave up or ran out right here. So you can see daylight through there. So that's going to be a leaky point too. So, and this is the drywall to top plate connection that I was talking about earlier. So this picture is taken in an attic, looking straight down to the top of this wall. And we can see there's a pretty significant gap right here and on both sides of this wall. And that's pretty tough to go back and fix. The beauty of new construction is you have the opportunity to do this stuff right the first time. Going back in and fixing existing homes can be a bit challenging. So you can spray foam the entire roof deck, or you can do what they did here and actually seal that leak up directly. You can use spray foam, caulk. Seen people use bucket mastic before. But yeah, that's a pretty big leaky point in most houses that are out there that didn't have intentional air sealing during the design. Chases are another big thing. We can see this big opening here. Maybe they were planning to run a duct down here and then decided to move it. But these need to be capped and sealed. This is essentially like having a window open at all times in the worst possible place of the house. So that's another thing to pay attention to on plans, where these things are typically overlooked in traditional code-built homes. Corners, anytime one material meets another, that's going to probably cause an air leak there. So like caulking your subfloor to the bottom plates, caulking corners. This one's not caulked here, but this is a 2-stud corner, so hopefully it's caulked back on the other side of that one. Windows and doors, obviously, using low expansion foam there is a good option like they did here. I have seen some builders mess up and use high expansion fire foam, which will jam up that window and ruin it pretty much. So always make sure it's low expansion foam if you go that route. But if it's a tighter fit in there, you can also use caulk. Backer rod also works as well. And our mechanical penetration. So this is like if you stick your head halfway into a ceiling return, that gap there between the return box and the sheetrock there, that's a kind of a double whammy. That's duct leakage and envelope leakage all in one. So basically what that does, that return's pooling, it's pulling in air from the attic through that crack too. So that's not what we want. So we want to have a nice beaded caulk to seal that up, and same for the supplies as well. And bath fans, any type of mechanical penetration, you want to keep that sealed. Recessed lights, these are always fun to work around. If you get the airlock lights, they still do leak a little bit. What some builders do, they'll seal something like this, but you'll still get some leakage through that assembly. So I've seen some actually build a box out of either plywood or drywall or rigid foam and set over that can light and then seal around that and actually make that box part of the air barrier to move around it. So there's products out there too made just for can lights to air seal. So there's more than one way to skin a cat for sure. So that's kind of a quick and dirty rundown on air leaks in a house. So now I'll kind of dive into the blower door equipment, what comes in a kit, and how you set it up. So whether if you buy RetroTech or Energy Conservatory, when you buy a blower door kit, it's a calibrated fan. You have an aluminum frame assembly that expands into the doorway and a cloth to fill the rest of that in. And you get a digital manometer, which is what's going to give you your flow reading. So these are basically the essential components here. And with RetroTech, you have the option, you can do this frame and canvas, or we have these expandable hard panels that pop into the doorway. Both work great. It's really just personal preference. But the frame and canvas is what we typically see the most. Just they're less expensive, but some people like the hard panels because they look a little more professional. And with our frames, they just snap together on the corner. So they're numbered on each end. So you match a number 1 with the number 1 and go and work away until you have your rectangle built. But we have different ones. If you mainly work with super tight houses that are going for like passive house numbers, we have a small window frame. So you can actually test leakage in the doorways too. And if you're dealing with flows under 1,000 CFM all the time, you can actually get away with doing your blower door test with a duct tester fan. And that's what this is here. And we have a canvas with a smaller hole for that to fit into it. So a lot of the guys that mainly test for passive house or mainly build passive house, sometimes this is all they use because that's all they need. They don't really need to generate much flow. But we also work on the other end too. If you have really tall doorways, like 8-foot doorways and stuff like that, that you build a lot, we have an extra large frame to fill those in. But yep, they pop together. And once you get this down pat, you can have a whole system set up in under 10 minutes usually.
Sam, do the hard panels leak less?
They actually leak a little more. It simulates a leaky doorway pretty much if it has like pretty poor weather stripping in it. But you'll probably get, I think it's 14 CFM more of leakage than the frame and canvas.
Thank you.
Yep. But that's what these look like. These are the hard panels. And so, yeah, where they leak are these seals where the panels meet. So we'll talk about how one of these works. So as I mentioned before, we have a fan that we set into this thing. And it actually has 4 little pickups. And the Energy Conservatory fans work the same way. So I think I have a closer, yeah, here we go. There's 4 tiny little holes here that pick up pressure, and there's an airtight tube that goes around the circumference of this yellow piece we call the nacelle of the fan, and then that ties into this yellow port at the top of the fan where your manometer plugs in. So what that's doing is reading fan pressure. That's how the manometer knows when your fan gets to 50 or when your house gets to 50 pascals of pressure. So no matter what house we test, if it's residential, we test at 50 pascals. That puts every house on an even playing field. And essentially what that's like is it's like a 20-mile-an-hour wind on all 6 sides of the house. So floor, ceilings, and all 4 walls. So, but on the other end, 1 pascal of pressure is a very small amount of force. So 1 pascal is equal to 1 gram over a square meter. So about what a paper clip does. It's actually a small amount of pressure. So if you worked in HVAC and you're familiar with inches of water, there's 250 pascals in 1 inch of water. So this manometer is what we're actually calling micromanometer. It's accurate within 100th of a pascal. So it has very, very granular sensors in there that are super accurate on this kind of thing. So that's how the manometer knows when the house gets to 50 pascals by reading that fan pressure. And it also has this red tube that goes through the canvas that reads outside versus inside. So that's how it's determining when that house gets to that point. Anytime you're using a manometer to read pressure, you're just reading pressure with respect to another area. So here it's outside with respect to inside. And then we call this a 2-channel manometer. So it's actually two manometers built into one. So it has channel A and channel B. Channel A is reading outside, inside. Channel B is reading your fan pressure. And when we get a blower door reading, we can interpret it a couple of different ways. What it gives you is the leakage in cubic feet per minute at 50 pascals. So usually when you hear a blower door reading, it's going to be a number and it's going to say CFM 50. So that's 1,000 cubic feet per minute at 50 pascals. Or we can do air changes per hour. And for that, you need to know the volume of the space you're testing. Not often is that going to be on the plans. A lot of times you just need to figure out what that's going to be. If you have some weird details or some vaulted ceilings or like that, it's going to take some extra measurement to figure out what that is. But you can actually enter the volume into the manometer, and that way it'll give you air changes per hour in real time. So that way there's no extra math needed. So depending on how you want to interpret it, the manometer will do it for you. So yeah, so there's basically 4 little pinholes in here, so it's important to keep those clean. Sometimes they can get gunked up if you test a lot of dirty spaces. There are ways where you can test to see if they're clogged or not. I've got some videos online on our YouTube channel on that if you want to look into that. But equipment maintenance is it's another hour-long discussion on itself. So this is essentially what we're doing when we test a house. We can test in either direction. But I like to test and to depressurize the house. You can either depressurize or repressurize. The reason that I like to depressurize when I can is because you're pulling bath dampers and kitchen dampers shut instead of blowing them out. So you'll actually get a little bit tighter number and not include those in. Some people get more detailed and they'll test in both directions and take the average. When we test commercial buildings, that's what we're required to do. But for homes, that depressurization number is enough to tell you what's going on. And that way you're not including those dampers that'll blow open. But with respect to outside, the house will be negative 50 pascals, which means right on the skin of the air barrier is a positive 50 pascals. So, and this is helpful because if we have another manometer that can read pressure, we can go around the house and look for pressure differentials to find leaks that way. So we can actually find leaks with a manometer that's just reading pressure on both channels. So again, that's another diagnostic we can talk about later on. But this is essentially what you're doing to the house. And again, it's like a 20-mile-an-hour wind hitting all 6 sides of it. So so what you're doing is you're exaggerating those air leaks. 50 pascals is enough pressure to balance out the house to see what's going on. So you're just artificially moving air through every leakage point, and the fan is able to calculate flow from that. And the reason that is, actually, I'll get to that in a second. So here it is, again, depressurizing versus pressurizing. You just flip the fan around. That's really all you do, and you run the test the same way both times. Just with pressurizing, you'll blow dampers open, and you'll likely get a higher number. So we'll quickly talk about setup, and we'll just do this with the frame. All of our products come with a hard copy quick guide on how to set up anything, whether it's a frame or a fan or a manometer. So again, like I mentioned, you just pull those frame pieces out. It comes in this little shoulder sling. Get your rectangle together. Again, they're numbered, so match 2 to 2, 3 to 3, 1 to 1, 4 to 4. And they just pop in like so, and you have a nice rubber seal all the way around. And it has these little cam levers on each piece, and so you just loosen those up, and that'll allow you to spread that frame out to fit the doorway. And then there's a cross piece. We give you 2. One is where the fan's gonna hang from, and then we have another one to give you extra stability towards the top. Last thing we want is that thing blowing out of there like a sail. So we want a good tight fit inside the door there. And then we get our canvas and just spread it out on the floor. And then it has these little Velcro tabs where we can fasten it into place. And then we pop it back into the doorway. and then we make sure everything's nice and tight. These cam levers, we tighten them down, hand tighten them down, and then you flip it, and it gives you some extra tightness in the doorway there for a good snug fit. And you just do that all the way around and on both crossbars. And then we set up our tubing. So for our tubing, it all comes bundled together in one piece. We call it the umbilical. It's got your tubing, your data cable, and a charger cable for the gauge. With our manometer, it charges with micro USB. So just so you're not dead in the water, we put a USB port on the fan itself, so that way you can charge the gauge off the fan if you forgot to charge it the night before. But all that's bundled into one piece. But one piece is a red tube. So if you just remember, red tube goes to red canvas, and you just pop it through this little hole down there and throw it off to the side. And you want to get it off to the side at least 5 feet away from the fan. You just don't want the fan to affect it. You want this to read kind of a zero pressure outside. So
Sam, if you forget to throw that out, you can always do the crawl of shame.
The crawl of shame. Yep. That's just when you have to crawl through the hole yourself. And we've all been there. There's people who've done it and people who haven't done it yet. It happens to everybody. But yeah, this is how you don't want this cord set up this way, because that fan's going to manipulate the end of it. So you want to throw it off to the side, like in the second picture here. One difference that I need to mention that's different between the Energy Conservatory and RetroTech is if you're pressurizing with a RetroTech system, you do not need to add an extra tube from the outside. With the Energy Conservatory, you need to add an extra tube or your reading will be 20% off. And the reason that is because the fan is manipulating pressure inside the house, and so you need to cancel that out. With the RetroTech manometer, it actually feels that fan pressure on one of the open ports and then mathematically removes it. So that's one of the setup differences between the two brands there. But once we get to that point, we have this little shower cap cover. Both brands come with it. So we just pop it over the inlet side there if we're going to set up to depressurize. And then there's this little elastic hole. Again, both brands set up the same way. There's this lip around it, and it locks it into place. And then you strap the handle into the top just to hang it a few inches off the ground. And then for us, everything's color coded. So yellow hose to yellow port on the yellow fan. And then you put the other end on the yellow port on the gauge, and then, red to red. And then we have this data cable here. It's a Cat5 cable, and this allows the manometer to control everything. So there's a manual dial on the fan, but you don't really need to use it. You can just enter 50 pascals on the gauge and hit go, and it'll run the fan by itself. You just pop everything in like so, and the fan comes with this little pocket on the bar, so you can keep it up there and not have it lying on the floor or something. And of course, we got to have power. Plug it in the wall. If you get into any larger testing where you need more than one fan per circuit, or you're going to be tripping some breakers. And there's this green status light. So if that's ever blinking or red, and you have everything plugged up, that means your Cat5 cable went bad, or the gauge is not reading a fan. So as long as it's on, green, and steady, you're good to go. But if you notice that it's blinking or turning red, that means try a different cable. It just might need to be replaced. So that light does have some meaning to it. And then we're good to go from there. I'm going to talk about some house setup in a minute. Talked about that. Yeah, so the term Pascal is named after a French scientist, Blaise Pascal. And again, it's 1 Newton of force applied over 1 square meter. So very, very, very small amount of pressure.
Sam, I always like to say that one PSI is equal to almost 6,700 pascals.
Okay.
So it's like you said, paperclip, but it's enough to get a reading without damaging the house.
Exactly. And we'll get into this later, but yeah, I like to start the fan off at 25 pascals if it's a new house I haven't been into yet, and then just kind of walk around and see if there's any weird smells or anything like that. Make sure all gas appliances are off and things, and then start up. I did a test one time on a house that sat vacant for 2 years, and all the P traps emptied, and I didn't check them. And yeah, it was. I did not have that fan on for very long. It was awful. So yeah, start off light, walk around, check for anything weird, and then once it all seems okay, especially houses with fireplaces that have been used, like if it's a wood burning fireplace and you're depressurizing, that's one of those instances where I like to pressurize instead and not pull that stuff inside. Another one, if I know there's mold growth on the air barrier somewhere, I don't want to depressurize and pull that stuff in. So pressurizing is a good point there. And then this is worth mentioning too, like if you're working with older existing homes, if you know that there's vermiculite insulation in the attic, do not run a blower door. That is the only time I say you don't run a blower door test. So there's actually a trust fund out of Charleston. I think it's the Vermiculite Institute or something like that, but they'll usually cover about half of the remediation to get that vermiculite out and better insulation installed. So
Sam,
if you come
can you
across
talk about
that,
why it would be important not to pressurize? I understand why you wouldn't want to depressurize
yeah.
and pull all the friable particles into the air inside the house.
So
but assuming that the attic's always open.
Even when you pressurize, you're going to disturb that insulation. And once it goes airborne, it can fall down through leakage into the walls. We just don't want to disturb it at all. And no matter which way you test, it's going to disturb it. So it's better be safe than sorry. That's our stance on it. But yeah, back to pressure here. Like I mentioned before, 248 pascals equals 1 inch of water column. So a lot of HVAC contractors don't really deal in pascals much. They're usually dealing in inches of water. So it's kind of a new metric for them to learn, but it's just a smaller pressure on a smaller scale. Let's see here. So this is if you look at the top of the manometer, that's just color-coded ports. So channel A goes to outside, channel B goes to the fan. And again, it's 2 manometers built into one. So there's a pressure sensor on both sides, and they're just working together. You just have to have all of that together to be able to get the reading from the blower door. And I pretty much covered this earlier. We tried to make this as easy as we can with the color coding. If people are colorblind, there's not much we can do about that. But we call it, we don't call it idiot proof, we call it idiot resistance. Some people still have screwed it up before, but we tried to make it pretty simple. So if you're looking at the gauge, channel A is here on the top, channel B is on the bottom. And so you can get different displays to come up here for channel B. You can have it read pressure on both channels, and you can have it read flow. But CFM is what you want it to read here on channel B. So this is if you're doing a blower door test and you're doing it right and it all falls within the fan's limitations, you'll have your 50 pascal reading here on top, and then whatever your flow is will be down here at the bottom. So that channel B is going to give you that magic number you're looking for. So that's just an example there of a test. So that house tested out at 1469 CFM at 50 pascals. You can also select your device here. So if you have multiple fans, this gauge will actually run Minneapolis TEC fans too. Or it of course runs all of our fans as well, duct testers, things such as that. So we tried to make this interface as simple as we could. So you just actually tap a picture of the fan, and it'll give you which range you want to set up. And then it'll also allow you to cycle through the different fans you can select. I've got other slides on that. So this is one of the most common questions we get for people that are starting out is, how do I know which range to go to? Like, how do I know where I need to be? Basically how this works is the larger or leakier the house is, the more the fan needs to be opened up. And then the other way around, if it's a smaller or very tight house, then you need to choke it down some. We have to do this because we have to maintain fan pressure within the shell of the fan here, so that the manometer can actually read pressure at the center of this fan, like I mentioned before. So if we have a really tight house and we're running it wide open, this fan is going to be barely running, and it's not going to generate much pressure. So we have to choke it down and put a smaller opening on this. And the way that a blower door is able to calculate the reading to flow, if you know the pressure of the fan and you know the area of the hole size, which the manometer knows all of these on all of these settings, then it can calculate flow. And so it's just doing the math for you there inside the gauge. So that's how it's able to spit out the flow of the leaks throughout the house. So if I'm starting out with a new house and I'm not really sure what to expect, I always start with ring A. This B8 plate, we call it B8. We used to have more rings in our older models, but now we just have one ring and a plate with holes. This just sticks on magnetically, so it's super easy to pull off. And then these range plugs just pop in and out. And then there's pockets on the cloth where you can just pop them in there to keep them off the floor. So we did this design this way because there's no moving parts. There's no little tabs you have to move around that'll break off down the road. So it just tends to hold up longer. But I'll usually start with A if it's a house I'm not really sure what to expect. And then if I can't reach 50 pascals, then I'll open it up. Or if I'm not getting a flow reading, then I'll choke it down. And so that's usually a good starting place. If you're always starting with tight houses, then go ahead and just have the B plate in there. If you do super tight houses that usually come under 1,000, this B4 range is a good place to start. So, it's kind of like changing, depending on how fast you want to go, it's like changing gears in a car. You just got to find that sweet spot. So that's essentially how that works. So the leaky or larger the house, you have it open. The tighter or smaller, you have it closed. And again, if you can't reach 50, you open it up. And if you can't get a test pressure, you choke it down. And then we have this at feature too. And what that does is, say you have it open and you're running it wide open and you can't reach 50 pascals, say you get to like 45. What this does is it extrapolates the reading and just does the math for you and says, well, if we could reach 50, here's what the number would be. And this is only accurate within 20% of the fan's ability. So our Model 5000 will do a little over 6,000 CFM. So for example, like if you're only getting 15 pascals, like nothing's going to be accurate there. It's really time to seal some stuff up. But if you're getting close there, like 40, 45, yeah, you can just hit that at button and it'll tell you what that flow would have been if the house could reach 50. So it just gives you a little more leeway in case the house is super, super leaky. We covered this. Yeah, and so I mentioned air changes per hour earlier. If we want to do that, we just tap on channel B and it'll give us this list, say ACH, so we just tap on that. And yeah, anytime we want to go back home, like anytime we get down to the list of settings or something, you can just tap the power button and that'll always take you back to your home screen. So you don't have to keep hitting back. And then this volume icon will appear and you can just tap volume and then you can just enter the volume of the house there. And then that way the gauge will give you ACH in real time. Before we get into house prep, do we have any questions that we need to address in the list?
I think we're doing good. I think
Okay.
Keep it rolling and then
Yeah.
we'll move on after.
All right, we'll keep trucking. So this is really one of the most important parts and probably the most time consuming part of doing a blower door test is making sure the house is good to go. If we go to the IECC codes, it kind of really lays out some of the best practices. So for example, all windows and doors should be closed but not sealed. Latch the windows, but you don't have to tape over them or anything like that. All dampers should be closed but not sealed off. All interior doors should be open because we don't want to block off any part of the house. We want every part of that house to be able to hit that negative 50 pascals. So we don't want to shut any rooms off like that. Exterior doors for continuous ventilation systems and HRVs or ERVs should be closed and sealed. So this is one that's kind of tricky. So if you have ventilation that runs 24/7, then that's really the only time you can seal something off. it's not very often that you have devices that do that. Usually they're on a timer and only run, maybe 8 hours a day or something like that. There's so many different ways to do ventilation these days. But if it is a system that runs all the time, then you can seal it off. Heating and cooling system should always be off. And then you don't really do anything else with the HVAC system. So no need to tape off returns and supplies and stuff like that. Because remember, the ductwork is also part of the envelope. So you want to include any duct leakage into that number. So we want to go check out the crawl space, look for any weird holes or anything like that. We want to check out the attic. We want to look for if there's, if this is an existing home, we want to see if there's mold, because if there is mold growth along like a floor or attic or something like that, we don't want to pull that inside. We want to check out the duct system. Anybody ever been to an existing home where they never shut the crawl space door and cats started living in there? It's a nightmare sometimes. So we want to see if anything funky like that's going on. I had a friend that bought a house last year where that happened, and yeah, it didn't take us long to find that. Yeah, doors and windows locked, garage door. People go back and forth on this. I say leave it open. ResNet says leave it shut. But if you want to test at the man door going into the garage, then you can open the door. But typically the garage isn't going to be considered part of the air barrier. But again, it depends on what standards you go by. Some say we want the house in its natural state where the garage door is typically shut. So that's why ResNet says that. But I like to test with it open, just pretend that garage wall is part of the outside. Checking windows, checking doors, checking fireplaces is important. Again, if it's a wood burning fireplace, that's when I like to pressurize and then start at 25 and walk around and just make sure nothing weird's going on. Combustion appliances, we want to turn those all on the pilot or turn them off. Pilot's okay. If it's a water heater or a furnace, yeah, you can leave it on pilot, and that's okay. But we just don't want any other fans running. We don't want exhaust fans running or dryers running or anything like that. But this next section here, it says for HVAC contractors, but builders, I think, should be just as aware of how air tightness affects HVAC systems, and especially how they're selected in the design phase. Not sure how familiar this crowd is with load calculation software, but when selecting an HVAC system for the home, one of the key inputs that it has to know is infiltration of the home. The house I just moved out of in Raleigh, North Carolina, 20% of the heating load came from infiltration. And if we get that wrong, I mean, that can determine, a couple of sizes. So this is why I say builders should be pretty familiar with this, because you want to be able to review that load calculation and just see where those numbers are coming from. Let's see here. There's some options to choose whether if a house is tight, semi-tight, average, loose, or semi-loose. What a lot of contractors do is just choose average, and because if they're not going to measure it, then why not? I mean, that's really the justification of it. But it could be loose. Like if you choose loose, they're saying loose is 8CH50, which that's a pretty common number to run into if you're just looking at traditional code homes. I mean, we've seen homes that are 20. And I mean, that's way, way off the scale. So if you don't actually measure and account for that, then you can really get your sizing off. And this can also help you dial in, like really, especially for an efficient home, you want to try to get the smallest system you can. And air tightness testing will justify if you can or cannot do that. I know one of the biggest problems that we see across the country is that there's none of this design that's really happening, and contractors just wing it and get the system way too big. And especially in areas like where I live in the Southeast, a problem with that is short cycling. It runs the equipment out faster, and we can't control for humidity. It gets to the thermostat set point way too fast, and which means the equipment doesn't run long enough to get humidity out of the air. So it just makes houses less comfortable. There's this common misconception that bigger is better, and that's definitely not the case here. So actually having a measured number to input into a load calc just gives you a lot more credibility whenever you choose a system to put into the house. So something to think about. And a question we get to is, at what point is the house too tight? And really, I mean, you get it as tight as you want. You just have to have a good balance between air tightness and ventilation. Airtight homes and mechanical ventilation go hand in hand. When we take away all of our air leakage, we take away that kind of natural ventilation that houses have always had. And so we need a mechanical way to pull some outdoor air in and filter it and control it throughout the day. So all kinds of ways to do that, all kinds of good products out there to do that. But it's important to have a good design for it. And for another one is like who can perform the tests. If you're trying to do it for code, different states have different requirements. But if you're just doing it for quality control, of course, you can just run them yourself and just make sure you're on path with whatever target that you have. And I'm not going to spend too much time on this, but our equipment has evolved quite a bit. There's a couple of testing apps out there now. This one's called rCloud, which will actually geolocate where you are, find the house. You can input certain characteristics about it, and then have a saved report from that specific house that you can always go to later. So if you're like Jake, where you like to do 3 different tests per house, you can have 3 different ports and always go back and see what that progress was for that house. So this is still free to use. You just download it and create an account. You can use a smartphone or tablet. It runs the equipment right from your phone, and then gives you a nice report with a map and has every aspect about the test. The weather that day, uses local weather stations to pull that in. So it's pretty cool, and you can always have access to that information. That's just an example of what the report looks like. And then we have this other one called Gauge Remote, which simply just mirrors the gauge from your manometer to your phone. So this actually has a Wi-Fi antenna in it, so you can connect it on Wi-Fi. And then that way you can walk around and have the controls to your phone, or have the controls to your fan and have a thermal camera on the other hand, and control fan speed without having to run back to the front door to adjust it. So just makes things a little bit easier.
So you can walk around the outside and find the leaks from the outside while the fan's going.
Exactly. Yep. And we have it for PC too. So this is a good training tool. So if you have guys that you're trying to teach this kind of stuff to, it allows you to put our gauge really big on the screen, and you can run through different scenarios and things like that. So I use it when I train people a lot. And then I had a few slides on here about whole house ventilation. This is one we see a lot, where you just have a duct running from the return side of the system to the outside, and it has this kind of air cycler system on it, which is basically a switch and a timer. So if you want 8 hours per day or 20 minutes per hour or whatever, you can set it to do that, and just have the air handler run the fan to bring outdoor air in and run it through a filter before it hits the supplies. I won't get into that today. And as far as finding the leaks, this is the smoke generator that I mentioned before. This is one that we sell. And it's basically just a handheld fog machine where you can go around and spot check different areas. Or if the house is finished, sometimes you can eject it in the middle of the house somewhere, and you can follow it, and it'll kind of take you to the worst area in the house. We just bought a new place in Wilmington, North Carolina, and it led me to a faulty window in less than a minute. So just a way to see what's going on. I doubt that video will work, but we have a larger system for that too, so you can actually smoke the whole house and then go stand outside and see where it's coming from. And I can't not talk about thermal imaging. This is one thing that I want to mention, is that what some people do is just run the door at 50 pascals and go do their thermal imaging, when really you want to run it at a much lower pressure. Because sometimes if you over exaggerate that leak too much, it's hard to tell exactly where it came from. So there's actually a standard that says that the pressure differential should be 20 pascals or less. So this is pictures from my friend Jay Bowen. He's a thermal trainer up in Green Bay area. And so just looking at this one leak from 5 pascals to 10 to 25 to 50, that's just one example. But if you get a more complicated leak in a wall somewhere, if you run it all the way up to 50, it may be difficult to see exactly where it came from. So I usually start around 15 and walk around with my camera, and then have my controls on my phone and bump it up from there if I need to. So just looking at leaks there. But Thermal cameras are so cheap now. I mean, you can get a FLIR one for your phone for $500. And for what we're trying to do here, they work fine. I mean, you can get good enough pictures to see where your problems are. That's an attic.
You have the temperature differential. You got to have,
Yeah, you
be
do.
hot inside and cold outside, or vice versa.
Yeah,
To work,
we
right?
recommend at least a 14-degree delta T. You can get away with less sometimes, but usually that's ideal to have at least that. If not, then that's where the smoke testing comes in handy. You can fall back on that. Yep. But yeah, this is an attic knee wall. These are notorious for being super leaky because usually they don't have some kind of rigid backing on the back. Like this house we just got now, I've got to tear into it to get a new attic access and do that. So that's going to be a fun hot summer project that I'm going to do. Where porches tie in, this is a wall with a porch that ties in. A lot of times there's beam pockets leak. So that's what we're seeing there. So any penetration in the ceiling, it just makes these problems visible. So especially if you're working with a client or a homeowner, doors with poor weather stripping. We missed some insulation there and we have a leaky wall. So, and again, this is at 15
Door looked
pascals.
like a portal to hell.
Yeah. And that's just at 10 pascals. So yeah. And then finding really small leaks there. Like for example, if we were looking at that wall, if we were just blasting it at 50, it may be really hard to pinpoint exactly where that was coming from. So plumbing stack not sealed through a top plate. So all kinds of problems you can find with thermal imaging. Thermal imaging and blower doors go together really, really well. So when you can exaggerate those leaks, it's really, really easy to make them show up. This is that ceiling grill, return grill that I showed earlier that wasn't sealed. So that's a leak we can see there. Outlets are notorious too. Windows. Uninsulated attic hatches, those are easy to get to pop up. You can see if the gas is still left in the window or not. So we can see these top two have expelled. This one's on its way out. This one's still okay. So I'm getting towards the end here. I want to talk about a couple of new things that we have coming out that are going to roll out this year. This is what's called the smart cloth. So this will end up replacing the cloth that comes with our blower door. This actually has tubing stitched into it. So there's no need for the red tube to toss outside anymore. So what this helps is with wind dampening. So when we start a blower door test, we have to do this thing called the baseline test, which allows us to remove the wind factor outside. So you let that gauge balance out for a little while and then take an average, and then it kind of removes that from the equation. It's like zeroing out a scale before you weigh something. So you're trying to remove that wind issue. But sometimes it's hard. On windier days, the less accurate your test is going to be. So what we've done here is put tubing in the fabric itself and branched it out in a couple of locations. And we actually did some tests with it. This is on a day in Washington State where we had some 20-mile-an-hour winds, and the blue dots are the conventional way. The kind of orange dots are with the smart cloth. So you can see that the wind didn't affect it as much as the conventional method. So that's just a new product that we have coming out to try to deal with the wind issue. Because there's never really been a product that's dealt with that, and it's always been a problem. So that's one way we're trying to tackle it. And then this is a new smoke emitter that we're coming out with. So the one that we have now is made by a company called Look Solutions in Germany, and it costs $1,000. So we're making our own and going to sell it at half the price of that. And it's going to be just a handheld smoke gun, and it'll have Bluetooth on it, so you can actually discharge it from other locations. So if you're doing like a mock-up test on a window, you can actually set it inside that test assembly and discharge it from the inside. Or you can put it on an extension pole and get it up like 30 feet if you need to, and still discharge it from your phone. So that's something new that's going to be rolling out this summer. And that's what I've got. We've got a YouTube channel. If you go to YouTube and search RetroTech Energy, we have videos, webinars on all types of topics. So thank you guys for having me on today, and ready to take any questions that might be left over.
Thank you so much for that, Sam. That was very thorough, but also still very concise. I'm kind of excited about the products. It seems like you're kind of looking out for the one-man gang, somebody rolling out that's wanting to run this test. I don't know that much about energy auditing. That's why I asked Emily and Randy to be on with us. But my understanding is that the the way that a lot of these problems get solved is one person being extremely thorough from start to finish, from doing the test to actually chasing the problem to actually fixing the problem. Would you agree that that's a pretty fair assessment?
Absolutely. Like just running the blower door test itself is pretty fast. But yeah, it's when you get into where like hunting those problems down. That's the time consuming part. That's where people usually start charging by the hour. Um,
That's a
but yeah, I mean, and we're just trying to come out with stuff where maybe, maybe somebody can get to 3 houses in a day instead of just 2. So, we've got the accuracy, both companies got the whole accuracy thing down a long time ago. So now it's really just, trying to make things quicker and easier.
That's perfect.
Yeah.
Well, I'm going to do some quick housekeeping that I should have done at the beginning. I was super excited for Sam's presentation, and I did not bother to introduce any of our other guests. Even though I mentioned you guys, it's not really fair to you to ask you to come on and then not give you a chance to say anything about yourselves. So I'm going to kind of work through that really quick. And then obviously I wanted to remind everyone in attendance tonight that certainly the chat box is the spot for questions. I took for granted that everyone's so used to Zoom now that everyone's like, oh yeah, I got that. But certainly if there's something that's gnawing at you that you think maybe Sam or one of our other panelists could help you with, please throw that in the chat box. I'm watching that. Rob's watching that. And then I will now do what I should have done at the outset, which is to thank our generous panelists for sharing their time with us. Again, I invited Emily Mottram and Randy Williams both on because of their energy rating experience. And I do have a series of questions for them too, but I just want to give everyone a chance to introduce themselves. Nathan Shirai from Insulation Unlimited I mentioned, and then Jake Bruton as well. But I'll start with you, Emily, because I see you every Thursday, and you and I talked about this before. And I know that as soon as we started talking about it, you immediately rattled off like 3 things that were like, oh, that's a game-changing tip that anyone who would be getting into this would just tremendously benefit from. Like you said, oh yeah, I just throw the fabric over the door, and then I set up my frame in a much easier way, and then put the fabric over it. So let me introduce Emily Mottram of Mottram Architecture in Maine. And please, Emily, take it away, share some wisdom and anything else you want to share about yourself that I should have given you a chance to do at the end.
No, that's plenty. I'm in Maine, lots of energy auditing. I'm a HERS reader. Did a lot of energy auditing. I've done so many blower doors at this point. I don't even know how many anymore. And you get into tight and dirty locations, you learn some skills real quick. First, I'm short, so throwing the red sail over the door and then propping the frame up against the sail instead of trying to find a flat spot on the floor to lay it out saves so much time. So if you have a door in there, you just throw it over the door frame, prop the frame up against it, put the Velcro over, plop it back in the door. I also never take my frame apart either. I just collapse it down to the smallest part because it can be difficult to find places to put your frame together. If you've been in a tight house, tight location, maybe the best door to do it is at the base of the stairs and you've got 3 feet to work in. So, it gets kind of crazy and awkward. I'm super excited about the built into the door wind problem, because that's a major issue that, we've tried the whole tennis ball on the end of the, I don't know. I think
the Coke bottle.
Yeah.
Yeah.
Everybody's tried it all. None of them work real well. So
going back to not taking the frame apart, we have a lot of customers that work out of work vans, and so they'll actually put DevCon into the frame connectors and just permanently glue them in there so that they never come apart. So yeah. Well,
I don't have a retro trek. I have a Minneapolis, and after a while, those buttons get really hard to push to get them in and out.
Yeah.
So you just leave it together. It all works great for me. So I don't remember what else we talked about, Travis. Something else cut.
I think that was the gold.
Yeah.
Hey, Sam, real quick, I'm going to ask you to stop your screen share. I think we're on to pretty much the discussion aspect. But yeah, those were you were moving too fast for me, Emily, when you were sharing all your wizardry. I wasn't able to keep up, but those were the 2 that I was like, oh yeah, that's brilliant. And obviously someone getting into this wouldn't think to do that for many years until they realized, oh yes, this would be way better. So since a lot of the people that I think are in our local group are considering moving to a blower door, I was like, let's just let them make that jump ahead based on the expertise of someone who's been doing it for a while. And again, that was something that I wanted to talk to you, Randy, about. having Randy Williams on is always a pleasure. He was kind enough to join us in person before COVID, and to join us again, I really appreciate it. But I thought, who better to tell us how us builders can avoid being on one of your energy audit videos where you highlight a failure that the builder put it just, intrinsically into the design and then executed so poorly that Randy has to come in later and fix it. Like, what are you seeing the most of in your testing and auditing up there that we could stay out ahead of with your wisdom?
Just identify where the air barrier is. A lot of the builders I'm running into aren't paying attention. Is it, in my climate, we're using a lot of poly, and that becomes the main air barrier. And I don't think the builders are really paying attention to that's what they're doing. I'm trying to move them to get them to move to the outside. Jake does a great job on a lot of his videos showing us how to seal using zip or using some of their system, some of the poly or the fluid applied to make sure we're sealing all those penetrations up. I'm struggling with a guy, with a builder right now, brand new place, a duplex. He tested at 4.2 air changes per hour. He went through, he tried to seal up the best he could. He had the insulator to back in to try to get in the attic and try to find some holes. He got it down to 3.8. After half a day of work, it's way easier to do it right the first time than it is to try to fix it afterwards.
Yeah, that makes sense. And that's kind of what brings Nathan into the fold. Our friend Nathan Shirai from Installation Unlimited down in Chattanooga. I, again, thank you for being on, and sorry for the crappy introduction. That you deserve better. But I know that you are primarily in the business of coming in and resolving these problems, not just on new home. Obviously, you're out ahead of the game, but I know people bring you in after, and with your BPI rater status, you're probably knowledgeable on all sorts of problems and solutions. What are you seeing, and what's the path to victory from your perspective with this?
Well, I guess if you're asking about occupied homes, find the leaks and seal them is really all it amounts to, which sounds a lot more obvious than it is sometimes. But the blower door is a super useful tool for kind of tracking some of that stuff down. So one thing that I've learned about in the last year or two that we haven't mentioned yet is something called zonal pressure diagnostics. And I see some heads nodding. For any of you guys who don't know what that is, it's sort of a way of kind of pinpointing where maybe your priority places are, and kind of establishing relative degrees of connectedness from your conditioned space to whatever unconditioned space you may be trying to diagnose, whether that's an attic or a crawl space or the outdoors or what have you. And so to try to condense that for you, you're going to turn your blower door on and just kind of let it sit at a known pressure. I think typically you'll stay at 50 for that if you're trying to measure those degrees of connectedness. And then you're going to take ideally a second manometer around the house with a pressure tube attached, and you're going to throw that into a room, and you're going to close the door and stand outside so that tube can see into the room, and the rest of your manometer is kind of seeing the rest of the house. And if you're seeing a reading on that gauge that is let's say you're depressurizing to 50 pascals, and if you're seeing a reading on that gauge that's somewhere in between that, then you'll divide the number into 50 to get a percentage of connectedness to the outdoors, because ideally the pressure in that zone shouldn't be any different than the pressure in the rest of the house. And if it's getting a difference, then it's getting relief from somewhere, the outdoors, the attic, the crawl space. And so you can start to kind of pinpoint where things are coming from and what the issues are that way. We call it playing Ghostbusters, which is a lot of fun and hard to convince people to pay for. But when we can, it really helps us figure out, okay, like maybe air sealing your attic's not as big of a priority here. Maybe you don't want to spend the money for that, but man, you've got a gaping hole in your crawl space that really needs some attention. So it can help with some of those sorts of things.
Yeah,
Yeah,
that's what I was.
that's a really quick and easy way just to find out what rooms are giving you problems.
Yeah.
And then we see this a lot after contractors will do a spray foamed attic. It's a quick and easy way to see how connected that attic still is. If you're still getting like a big pressure differential from that attic to the main space, you definitely miss some spots. So yeah, for sure. For crawl space, it's the same. When we do an encapsulation, you can do that same process to see what issues you missed down there. So yeah.
Yeah, that's great. I think I can take this with Jake as well, and I think everyone knows Jake. But Jake, you can certainly tell people who you are. If I was going to restate the way I asked that to Nathan, I was kind of thinking, what are the target areas in order, sort of a priority order? And I think it applies for new home as well as remodel. So Jake, if you'd want to grab that, I know people always talk about, oh, your attic door, your rim joist, can lights. You want to run down the list and sort of strategic attack that?
Yeah. Number one, I'm drinking Logboat Brewing's Rosalita Double IPA. Nobody talked about their beers. Number two, nobody said, hi, Rob. Thanks, Rob, for moderating all this. You got to give credit where it's really due.
Thanks,
I think the number one problem is design. It's not can lights. It's not the sill plate. It's building houses that were never designed to consider air leakage to begin with. I went to another builder's project this week, and he said, hey, do you want to stop by for 10 minutes and check and see what I have going for my air barrier? And his air barrier is on the ceiling, same way we do a lot with just drywall. He had 15 different ceiling heights. There is absolutely no way that is going to be as easy to execute as one or two ceiling heights. Outside of that, it's all stack effect. That window on the second floor of a three-story house is not going to leak. The can light and the sill plate are the first place to start. Anything that's poking through the ceiling, anything that's poking through in the bottom foot of the wall. So, but design is design's the key.
With that in mind, are you taking attic accesses out of your conditioned space, throwing them in garages, putting them on gables? What are you doing?
So I haven't until a project that we're working on right now. And Ben Bogey gave me a bunch of flack about not just putting it on the outside of the house. And he's like, you know what? You don't want your clients going up there. Put it on the outside. Make it so you have to get a screw gun to get in. And I decided to try it, and after trying it once, it's going back inside. I'm not fiddling with putting it on the outside. I'm not going to deal with siding details or having to draw a map to the clients to post in the mechanical room as to how to get in there. We're going to put it back inside, and we're going to put some of the lunchbox-style clamps that we put on now. And we do weather stripping and lunchbox-style clamps and a piece of Advantech that's all like above where our little drywall panel is.
Good solution. Yeah, I have botched this from go. So yes, thanks, Rob, and thanks, Fine Home Building, and thanks, Green Building Advisor, and thanks to the panelists, and certainly to our guests, or excuse me, to our attendees. We do have some questions in the chat box that we should just kind of open it up because it's free for all now. I finally took care of the housekeeping. Better late than never. So if I was rolling up through here, I was going to see. There's a question for you, Sam, about how much would a base setup cost? I think that's a pretty common question. You want to hit that one real quick?
Yeah, so it's about $3,500. I think ours is $3,595 for just the basic 5,000, and Minneapolis, I believe, is roughly the same. So,
and that gets you.
Doesn't
the
matter
door,
if you're going to use it all the
fan.
time, right? It doesn't matter if you're going to use it 3 times a house per house that you build. It's going to pay for itself.
For sure, yeah, especially with issues down the road. I mean, with quality builders, I mean, they want to make sure that the occupants are going to be good and satisfied and happy for years to come. I mean, how often does a builder come back to you 5 years later? Well, how are things going? I mean, it never happens. But when you go ahead and knock this stuff out from the beginning, you know you're not going to have any issues or have any callbacks. So, for sure.
Yeah, solving those comfort complaints before you get them is the cheapest time you could ever solve any of them.
Yep.
1 or 2 visits to a house to address comfort, and you've paid for your door. So I certainly see the benefit to that there. There's another question here. let's see, it says, Jake, what was the biggest surprise you learned from blower door testing? Framing, sheathing, walls, foundation, anything?
So we probably 2 years ago, we pulled one of our doors and one of our walk doors and taped a piece of Advantech over the opening, and then put our blower door in another section of the house, and then we drilled holes in the Advantech to see what it did to our numbers. And we drilled like 4 1/4 size holes before anything noticeable happened on the door. So that's a big hole times 4 before we had any real measurable difference that seemed like it was going to affect the house. Also, if you're going to do that, drill the hole while you're pressurizing the house, not depressurizing, so you don't get a face full of sawdust.
Yeah, there's another cool feature on the manometer too, where you can change your readout to what's called EQLA, or the equivalent leakage area, and it'll actually give you the leakage area of the holes in square inches. So if you go and you tape something up, yeah, you can watch that. You can watch that area drop when you do that. Yeah.
Yes, I didn't know that.
Yep.
Doesn't matter how good the gear is if you don't know how to run it and you don't know what it does. I have that problem with my new truck.
Yeah.
I can't even make a phone call now. It's a disaster.
That equivalent leakage area thing is a super way to communicate this whole thing to the layman as well, especially the homeowner. Like
Absolutely. If you draw it out somewhere, like this is the size hole that we're trying to hunt down, but it's broken up into a million pieces.
You've got a whole size of a watermelon in your house. You know, that really is huge for communicating the value of all this stuff.
Yeah,
if
absolutely.
you don't have the DM32, so I wanted to make sure everyone is aware of this too. So I've got it here on my phone. I don't know how well this is going to work. Not well at all, apparently. What that is that you can't see is Rick Karg's website, Residential Energy Dynamics.
Absolutely.
And if you don't have the auto calculate ELA thing on the RetroTech gauge, like if you're still rocking the DG700 Minneapolis like me, he's got a calculator on. I don't even know why I'm using this anymore. Residential Energy Dynamics. It's called Red Calc, and there's a free section of that. And you can input your data for the particular house that you're testing, CFM, volume, and stuff. And then it will compute all of those things for you. So you've got equivalent leakage area, effective leakage area, which I think is a different standard, a few other things on there. So it's a really good tool for expressing some of this stuff in a meaningful way.
So Sam, we've had a couple of people asking about how many times or what stages people typically test at.
Yeah, I would say the most common test is when the house is move-in ready. I guess right after everything's powered up, unless you're just an animal like Jake.
Jake's giving you a thumbs down there. Jake doesn't agree.
Yeah, but that's the answer to the question. Usually people test at final. And there's typically some type of visual inspection that goes before the sheetrock is up. But if you have a nice air barrier up before you have your sheetrock up, yeah, absolutely do it then. It's so much easier to find where those problems are. But in many cases, the drywall, whether if it's the wall assembly itself or the ceiling, is part of the air barrier. So, but yeah, I always recommend to builders that are getting into this, put your ceiling, if your ceiling is part of your drywall, put that up first and go ahead and get that airtight, and then go ahead and find where your problems are. Even better if you have a spray foam roof deck, then you don't have to worry about that. But unfortunately, that's, a lot of builders don't, weave that into their schedule like that. But if you're really trying to find where these problems are, it's so much easier to do it before you close everything up.
Proportionate. If you're trying for really low numbers, don't wait till the end. Don't buy crappy windows. Don't buy a crappy air barrier. Be proportionate.
Yeah. Things get missed. No matter how careful you are, things happen. Things get overlooked. So, when testing and using the smoke and the thermal imaging, that's how you find stuff.
And we've seen this plenty of times where people, if they're using their sheathing as their air barrier, don't even bother cutting the holes out for the windows and doors, except for maybe one way to get in and out until they're done, so they can actually test that.
Yeah, that's great.
Don't underestimate the ability to hear a leak as well. So especially if you're on the outside of the house and you crank the pressure, like we took one last week to 150 pascals so that we could see if we could hear it. And we found one little leak that we could hear. We could hear over the noise of the fan, we could hear the little whistling noise of the air coming through there.
So Jake, what's the most dramatic way you've found a leak in a house? Anything crazy?
Actually, one of the things that we did was we had a concrete floor polished, and they had a lot of water involved in the polishing process. And I told them to leave it, and they left a ton of the water still on the floor, and we just had one opening, and we pressurized the house, and we pushed it up against the sill plate. Like we used a squeegee to shove it up against the sill plate, and we found like 5 leaks that were big enough that they let water come through that we didn't know were there. And we were already at like 0.3 or something like it was a ridiculous, like we didn't need to be giving that effort, but somebody was going to have to squeegee it out. And I was like, hey, we're going to do a blower door this afternoon. Just leave all the water and we'll shove it up against the wall. And so we just stood around for 30 minutes pushing it up against the sill plate with the house at 100 pascals of pressure, and then found 3 spots on the outside where the foundation was wet.
Yeah.
Wow, that's awesome.
I trust none of the rest of you folks are testing that way. You're not filling these houses with water to test. Are you mostly smoke? Are you you prefer thermal? What's your? I guess I'm sure you're going to say both, but where do you start?
Actually, Corbett Lunsford had a pretty interesting video of testing with the blower door depressurizing with a power washer going from the outside, looking for leaks coming through the wall. And when we get into bigger buildings like multifamily and commercial, rain penetration tests are very common and they're often required. So you'll have what's called a spray rack system, and then you'll depressurize the other side of the wall from the inside with a blower door fan or high powered duct tester or something like that. And then you'll watch that water be driven in. So yeah, I mean, it's definitely done in new construction and other areas.
Pre-drywall.
Yeah, well, not all the time. Yeah.
Really?
Yeah, sometimes it's a destructive test.
No kidding.
Yeah,
that is
they're
brutal.
Expensive. Yeah. So yeah, we've seen some funky stuff go down for sure.
Randy, somebody's asking for you to explain your background.
Okay. I am a energy auditor. I'm a former builder. I still do a little bit of swinging the hammer, but I'm an energy auditor, and I also do a little design work on the side. Back to Travis's question. I primarily use my thermal imaging camera. I've got a FLIR C3. Just because I'm in northern Minnesota, we're cold. That what's behind me, that's actually an air leak, which you see above me, on a house on a cold winter day, a brand new house that was being built. Matter of fact, if you follow me, that's the concreteless slab on grade home. We had a little moisture from painting and tiling and stuff that went out the that's an air exchanger. The moisture came out the air exchanger. No blower door testing. That's just natural air leak. It's easy to find air leaks in Minnesota with a thermal imaging camera, especially when it's 20 below, 30 below. Yeah.
Yeah, I've always been a fan of the pressure pan, which is kind of like the zonal pressure diagnostics that Nathan was talking about earlier, but in a more specific area. So basically what it is, it's a plastic box with a rubber seal around the opening where you have tubing that comes out that connects to your manometer. And so you can place that box over switch plates, you can put it over outlets, anywhere that there's a penetration, can lights, you can find duct leakage with it by putting it over supplies. And it'll tell you what's going on in that wall and how connected certain wall assemblies are to the outside. So that's just another way that you can, get more out of your manometer is by using that. And we just came out with a new one this year called the Flow Box, and it has 4 holes in it that uses our blower door range plugs to plug it up. So if you take one out, then you can use it as a exhaust fan flow meter to measure flows and exhaust, bath exhaust and kitchen exhaust. So it's kind of a 2-tool-in-1 thing.
Make sure you do that before you paint, though. I can't tell you how many times we've had dirt rings on the ceiling or
this
on
one,
a spot
this one
you're
doesn't
looking
leave,
for it and you're like, oh
this one
crap.
doesn't leave the black marks. So,
oh,
yeah.
That's awesome.
Yeah.
We had somebody
You're
ask.
talking about.
Oh, go ahead.
Sorry, go ahead, Rob.
We had somebody ask, what kind of numbers would you be expecting for retrofits? What kind of ACH numbers? I mean,
All
that's
over the
probably
board.
that's a huge open-ended question. I mean, it really
Yeah.
depends on the house. But
I
Yeah.
mean, anything could happen, really. I mean, I guess if you're just taking an existing home, but you put a really, really tight add-on to it, I mean, in some cases you can actually bring the number down. But I mean, if you're really adding on to the house, I mean, and just it depends on how much you pay attention to it. I mean, it's, it could go in any direction, but and it depends on how deep you go into it. Are you tearing drywall down? Can you get to the sheeting? Can you seal things up that way? Yeah, it just depends. Are you sucking out insulation out of the attic and doing air sealing there? So it really just matches up with the budget. Depends on how far you can go.
That's a hard question to answer because there's so many different house styles, so many different sizes of house. Is there an attached garage? Is there a stairwell that penetrates the envelope? There's just so many ways that can vary.
Yeah.
In our area too, we've got, houses that are 150 years old that, like mine, for example, I couldn't even get my fan up to 50 pascals the first time I tried to test my house. After a lot of work and adding on 500 square feet with 2 new bedrooms, I'm down to 9 air changes and I can actually get to 50 now. But before, I think, was it 27 ACH 50 that we kind of extrapolated to? So it's just going to vary. Most of the houses in our area, I would say, are going to start in the 10 to 20 range. And you'd be you'd have a big celebration if you were able to cut that in half. Probably 20 to 30% reduction is usually the most that you can get in our experience before you start taking the building apart anyway.
If you can tackle the ceiling, I mean, that's a good chunk of it right there. But once you have to tear into walls, I mean, that's when the project starts getting really expensive. So
Right.
Depends on what the budget is.
On retrofit, I think it's a pretty easy sell, especially for your 80s, 90s homes that are just chock full of can lights. It's a pretty easy sell to push a client to LED inserts for those. And there are varying qualities of the gaskets on those trims. But even if you're taking the existing can trim off, you can usually caulk the can housing itself to the drywall without ever going in the attic and getting itchy. And then put your LED insert in, and then you're really giving them 2 massive energy savings. You've solved the air loss, but you've also eliminated the crappy incandescent bulb and moved them down to 5 watts a year of usage. So that would be a strong suggestion for easy upsell for anyone that's wanting to go that route.
yeah,
And you got to think about the ductwork too. Sometimes, in older houses, ductwork is a big source for envelope leakage. So if you're going to swap that out, that can bring your number down a lot too.
and I think on existing houses, depending on how long you have access to the blower door, if you own it, obviously you can do it at multiple stages. But like, I live in a balloon framed 150-year-old house, and I had a blower door available to me for a 1 day. So what I did is I went ahead and just hit all of the obvious spots that I could hit first, whether it be sills or old can lights that had been installed, old closets that had, communication between the walls and the balloon framing, and just get that stuff done, do a baseline test, and then run the blower door while you go around and do some blower door directed air sealing and focus on it that way.
The access question, the access item of that to the blower door reminds me of the third thing that I got excited about when I was talking to Emily about this earlier. And that was something that she had talked to some of her locals about early on in her career was, you don't need your own, I'm sorry, Sam, you don't necessarily need your own blower door. If you and 3 of your favorite builder buddies want to go in on
Everybody needs a blower door.
Everybody. Most people need two. Is that what you said, Nathan? Well, you got to have two manometers to do the things that you were talking about. So, just keep it going, get them all. But if someone was looking to dip a toe in the high performance waters as a builder that's just wanting to come up to the coming code standards, since prescriptive path is going to go away, Emily was saying that was something that she benefited from early on was, we can, I don't need the blower door on Tuesday. You can use it Tuesday, and you can work that out. Unless you're just going to go ahead and get everyone right out of the gate. But that is something that I would like to see in lieu of not running these tests. It would be better than not running them, to work with a few friends and work it out. And if any of you are on the fence about it, definitely talk to Steve Basic. It's only been a year since I talked to him, and I was telling him what a great job I do, and he immediately jumped down my throat and he's like, well, what are your numbers? Like, well, I mean, we just do a really good job. So, I know that the numbers would be great. And he's like, you don't know anything. You haven't run a test. You don't have a door. You're guessing. It's all guesswork. And it was like, oh man, he echoes in my head on every job now. Like, oh God, I got to get the door in here.
He's right.
I knew he could count on you, Jake.
Emily, where did your house end up at? You tested your house recently.
Yeah, 8.5 ACH. Well, it wasn't great, but there also was a lovely picture of the giant hole in my ceiling. So all of us energy auditors and high performance, I don't know if all of us, but I find that a lot of us seem to start with something that's really bad and just keep making improvements to it. So we had a gas fireplace, or the previous owners had a gas fireplace that they took out, and they just kind of left the hole in the ceiling because it's in this closet. So, it's like a great attic hatch, just wide open to the ceiling. So 8.5. Wow. It'll make a big difference when there's not like a 2x3 foot hole in the ceiling anymore. Mm-hmm. So, especially
Emily, Nathan.
How many watermelons?
I just said, how many watermelons is that, Nathan?
So, Emily, when I got my first blower door, I tested the house that I'm in now, which is a 60s ranch with a pit basement.
Yeah.
And it was like 7.5, and I was disgusted. And then I immediately broke down the door, took it to a house that I built for my parents in 1999 that I thought I had done a good job building. And it was like 8.5. And I was like, well, I don't know if I'm going to ever tell anybody that. It got worse as the systems went on. And now I realize that it's like, regular old sill sealer and vinyl windows and like is all that kind of thing. But at the time I was like wildly embarrassed that I lived in a house that was like that and hadn't taken care of things myself.
Yeah, well, we'll all eventually get there, but then we're all out doing work every day, and so you get to your house sort of last. So
it's like the cobbler whose children have no shoes. Like,
pretty much.
Yeah.
Pretty much.
So Sam, I put up this picture when I called you 2 weeks ago to try to figure out what was going on with my manometer, and you said, "Well, why don't you just use the app on your phone?"
Yeah.
We built this box and we nested it around those two stud bays. Let's see if I can. Those two stud bays. And then we sprayed the zip sheathing and two nail heads that were overdriven, and then a seam that was taped. And then we depressurized to 150 pascals for 45 minutes, and we couldn't get a nail head to leak.
Wow.
So I'm pretty sure
That's
that
awesome.
We don't have to. And I'm so sad that Christine didn't get to hear that because she left already. I'm so like, I was just like, oh, well, okay, now I'm not worried in any way, shape, or form. I was barely worried before, but 45 minutes with that fan going at negative 150 with a garden hose on the outside.
So take back my previous statement, Travis. If you're Jake, you need more than one blower door, and you can't share it with your friends.
Yeah.
The irony of that statement is Jake has loaned me his other blower door. So
I'm going to need that back now that I know how to zone things.
I will definitely do that. I have overused your generosity already on a number of levels, apparently. I was just going to mention that Christine has gotten so many questions about the overdriven fastener that she went ahead and put up her own website. I think it's overdrivenfastener.com, which is hilarious because it's just like 3 pages of text. Like, this is why you don't have to worry about overdriving fasteners. It's easier to direct someone there than for her to answer the same question again and again and again. And now she has your research to rely on, Jake. So you should hook her up with that video feed. You guys should partner,
sure.
a collaboration.
Jake, do you have a video of when you guys did that? Did you film it?
Yes, I hate to say it because Fine Home Building's hosting this, but it'll be on buildshownetwork.com.
So Travis had mentioned that some people were interested in catching up on this video, and we'll definitely have it either on YouTube or our website or both, so people can catch up on, see what they missed. And I'll, if you go to finehomebuilding.com/webinars, we'll put a post of it up on there, or I'll give Travis some links that we could share on social media later on.
Cool.
Yeah, we'll definitely put that out on Instagram. When we get together live, this thing usually just keeps on running and people are standing in the lobby drinking beers and waiting to get kicked out. But I think everyone's had their fill of the Zoom life lately. So if we don't get a whole bunch of additional questions in, I would love to be respectful of our panelists' time. I'm really, really grateful for Sam coming in and giving us this baseline understanding of what is a pretty fantastic tool for all of us making things better in the built environment. But certainly the generosity of the panelists that I did a crap job of introducing at the beginning of the show. As I said, you guys deserve better. But I really am grateful for everyone sharing their knowledge and their experience. If anyone's got stuff they want to get after, I'm happy to stick around and get after it. But I don't want you guys to feel like we're holding you hostage either.
My family said I have 10 more minutes.
Ooh. Well, then tell us your greatest failures, Jake. Bare your soul.
I have a 13. No, I'm just kidding. I have a 13-year-old. I'm just kidding.
So we did have one question, guys, that was asked a couple of times. Sam, where did those percentages come from on that chart, the pie chart you showed about where the typical leaks are in a house?
Yeah, so Owens Corning did a really good study some years back. I'm trying to think. I think you guys have it on Green Building Advisor. It's called like getting the most bang for your buck or something like that for air leaks. But it really breaks it down.
Wolf.
Yeah, it was one of his studies, and they had a really nice chart breaking down where all these air leaks come from. So I always refer people back to that article whenever that question pops up. But ceilings are killers for sure.
Well, I'll try to.
You guys addressing. Sorry, Rob. Go ahead.
I was just going to say I'll try to track that article down, and I'll put a link in the post when we make the post.
Yeah.
Do we also want to throw a link in for the thing you referenced, Nathan, on your phone? What website was that?
Yeah, sure. I'll type that into the chat. But for the sake of the video, that's if you get on Google and look for residential energy dynamics. Or https www.redcalc.com, redcalc.com, and that'll get you there. There's a free section, and then you've got some ASHRAE stuff, blower door metrics. There's a sort of a suite of different things you can play with on there.
Yeah, they have a ton of calculators on that website. That's such a good resource.
Yeah, if you want to get into the weeds, Rick Karg is amazing. That's where I learned zone pressure diagnostics like 10 years ago.
Mm-hmm. Yeah, he's got some good videos out there too you can find. And actually, if anybody, I'm not sure, is anybody here participating in the Home Performance Conference right now? It's online this year. Maybe it's available to still sign up for. They've got a lot of online content that you can just stream on demand instead of having an actual like in-person conference at a hotel. And he's one of the people presenting at that. There's just a ton of good information about this very stuff on there if it's still available to get into.
That's a great resource. If there's anything else that people are kind of wondering about, or I guess looking to get their foot in the door on stuff, I I would just want to, I guess, express how wonderful everyone has been about communicating. I know I've said this before, but I'm just daily shocked about how great the Instagram building community is. I know that a lot of people find this through Instagram, so I won't spend any time on that. But certainly the available resources, the accessibility. I mean, I guess I had to ask Jake for Sam's number, but I had accessed Retrotech through just an Instagram DM. So I would really appreciate it if anyone is getting questions or comments that they feel like they need help with. Send them to me if you're not getting an answer somewhere else, and I'll ask one of these wonderful people, and we'll find a way to get you in the door and help you make your buildings better.
I would say if you have not tested one of your houses, I would pay a professional to come and test it, and then don't let them just get an ACH 50 number. Walk around and try to find where the leaks are while they're testing. Don't let them just go, oh, it's 5 ACH 50, and then start packing up their door. Go, wait a minute, we want to find where this is happening. We want to figure out where the problems are, and then from there, that'll help you decide whether or not you think you need a blower door so that you can find those.
That's a great tip. What's the starting, what's the going rate for an entry-level energy audit like what Jake's describing? I haven't hired one, so I don't know. Can Randy or Emily tell me kind of a ballpark of what you guys are charging in your markets for that?
So I'm charging for just the basic blower code compliant blower door test. It's only $200 is what I charge. I'm in and out in usually a little over an hour. It's maybe 2 at the most. If I'm searching for holes, of course, then it gets to be by the hour. You know, that one that didn't pass, I have a lot more time into that one trying to find where the holes were at. But for the basic one that passes right away, a couple $100.
Yeah, same here. It's like $250 for a code compliant if you're within roughly 30-ish miles of our office. You know, and this is Maine, if I got to drive halfway across the state, it's going to cost you more money for me to show up. I'm more likely to hopefully connect you with somebody else who can do it in your area. A full-on energy audit depends on the size of your house and a whole lot of other things in air leakage. And if you hire an energy professional, and like Jake said it before you let them pack up, and you want to look for air leaks, and you want to spend very minimal amount of money, there's this kid's toy online called a wizard stick. And they're like $20, and it's literally just glycerin. It's like a mini smoke stick. So, you know, I don't know how much your little smoke machines are, but it's just a tiny little wizard stick. You walk around with it, the thing smokes, and you can find a lot of air leaks that way. We used them when we were doing some more mechanical testing for backdrafting, but it works for air leaks too. So
there's a story about Joe Stieberich using a cigarette to diagnose issues in a hotel.
Not surprised.
I've heard that.
You know, resourceful. Maybe incense.
Yeah, anything that smokes, hopefully something non-toxic.
Right.
Yeah.
So one thing, I don't know of how many people know this, but especially in older homes with unfinished basements, is spider webs are a great place to find air leaks too, because spiders need moving air for some reason, catching bugs, I guess. And so if you walk around a room and you see a concentration of spider webs somewhere, there's a good chance there's air movement there.
That's a good one, Rob.
Yeah.
That's a great one if you have a client and you just tell them, oh, it's not that you don't do a good job cleaning. These cobwebs that you have in your house they're just air leakage. That works great.
So in other words, you could convince them that their house would stay cleaner if they had a tighter house.
It should.
It really should. It really should.
You have any idea how many people have apologized when I pull out their refrigerator or their stove about how dirty it is behind there? And I'm just like, stop. Mine's disgusting too. No, nobody cleans behind that. You don't have to apologize.
Sounds like a missed opportunity for upsell, Jake. I mean, obviously it's an air leakage issue behind the stove. You know, come on, let's get this going.
That's where
Okay, guys, thank you.
was gonna say that's where you put your ventilation in, so it blows all the dust bunnies out from under the stove.
That's right.
Ew.
Well, if Jake's leaving, I guess the party's winding down.
I guess.
I don't want to keep anyone, but I really do want to thank everyone who was able to join us in attendance, but especially our panelists. And again, Sam, thanks for the presentation. I really found it informative, and I think it will be useful to everyone who takes the time to watch it, take it in.
I'm down to drink beer and talk blower doors at any time. So just let me know when you want to do the next one.
We do this once a month, man. And the BS and Beer show is on Thursday, so you can drink beer with us in a couple days. You don't have to wait until next month.
Right on. Yeah, thanks again for having me on.
Thanks again also to Rob and Fine Home Building and Green Building Advisor once again for hosting the content. And as Rob said, it will be available online, and there'll be a link on social media, and so you can take all this in at any time. Oh no, there's one last question. Okay, for the smart folks still here, Joshua asked, did you all see my question about the makeup air? Do we know what that question is?
Oh yeah, he was asking, what do you do for makeup air once you start getting to really low air infiltration numbers in a house? When do you have to worry about that, and how do you deal with getting clean air in the house?
So by makeup air, is he talking about like for the kitchen exhaust? Because that's a common thing where when you get a tight house and you run your kitchen exhaust fan, you have makeup air where it's basically just a duct connecting inside to outside with a damper on it that opens up when you run the fan. We see that a lot of times, but I know some people use the term makeup air when they're talking about whole house ventilation. So there's a couple of different baselines for that. BPI has one where they just use the square footage of the building with the CFM 50 number. So if you have less than a 1-to-1 ratio there, where your CFM 50 number is lower than the square footage of the house, then it's time to start thinking about adding some fresh air in. In other states, it's required, like if it's under 5 ACH 50, then you need to have mechanical ventilation. So, and that's kind of where I stick around too. Like if you're getting under 5 ACH 50, it's really time to start coming up with a plan for that. So hopefully one of those two things answered the question.
Yeah, that's the code requirement here. 5 air changes at 50 pascals, you need mechanical fresh air ventilation. But yeah, I'd probably argue that makeup air is good for a point exhaust, regardless of how leaky your house is, so that you have more control over where that air is coming from and where it's going. Because otherwise, it's just coming in from all the nooks and crannies and weird places and getting those cobwebs going.
For sure. Yeah, we had a customer here in North Carolina that I worked with a couple of weeks ago that was working in Pinehurst on the golf course and had a huge house that was being built. And they put this ridiculous kitchen exhaust in there. And it actually it put the house 7 pascals negative when it ran. And so he was actually able to pressure match that with the blower door and get an estimate on the flow to figure out what that was. So, but yeah, that house definitely needed makeup air. When these houses like that put these huge commercial exhaust fans in, it's just not necessary.
Thank you for having me, guys. I've got to run. My wife has something happening here in a few minutes. It's been a real pleasure. I don't know how I made it onto this panel, but I'm glad I'm here. Good to see everybody. Y'all have a good evening.
Great.
Take care,
Thanks.
Nathan.
All right,
It was your expertise, Nathan. It'll get you every time. Be careful.
Yeah, that's right. Sam, if you're ever in Chattanooga, look me up. We're not too far away from each other.
Yeah, sounds good. Once this thing gets going again, hopefully I'll be traveling again. So I'll keep you in mind for sure.
Good deal. Good night, everyone. Thank you.
Thanks. See ya.
Thank you, Nathan. Anyone else parting words? Randy, Emily, Rob, Sam?
Oh, that was a pretty detailed discussion there. So hopefully a lot of people got some useful information out of it.
Yeah, everybody
I
needs
think it was
access.
tremendously informative.
Yeah, everybody needs access to a blower door, whether they own one or have a buddy that owns one. But it's a great tool. And for Randy and I in cold climates, the infrared is invaluable. But I think Steve does a lot with pressurized and does his air barrier. And obviously this in new construction, if you can get to it sooner, it's certainly a lot easier to seal it up if your air barrier is the exterior before you've got insulation and drywall and everything else up. So Those are my parting words.
Is
Yeah,
it,
just
the new version of a chicken in every pot, a blower door in every house?
A blower door in every one of those ridiculously cool mobile classrooms that I don't know if Matt started, but the mobile workshop. So those all need blower doors.
Well, thanks again to everyone, and have a great night. Thank you, Randy.
Yeah. Thank you guys again.
Take care, guys.
See ya.
Thanks, Rob.
Sure.